Okay, I'm going to go ahead and get started since it's almost 9:30. And today we are going to attempt to cover 5.5 and 5.7 so that we will have the time to review on Thursday. Before we get into the problems of 5.5, let's talk about the different rules of multiplication. When you are multiplying plain numbers, nothing is going to change about that in this section, okay? When you are multiplying plain numbers, everything is the same about that since you learned how to multiply in elementary schools. Same sign rules. Negative 7 times positive 7. A negative times a positive would give me negative 49, right? Now, the exponent rules that we learned last week when we are multiplying, sorry, I'm looking for my, are still going to be in play. For instance, when you are multiplying the same basis, x times x, that rule says you are going to add those exponents. So I am multiplying, but the exponent rule, the rule that just applies to the exponents is that you will add those exponents. We're just going to put the two ideas together now. Okay, number one has problems that explains all this very well. I'm going to write out the 4 different things on number 1. We have 5x squared times 6x to the 7th negative 5x to the 7th times 6x squared. So let's do these two first. Okay, so like I said, the multiplication rules are still the same. These are your plain numbers. That 5 times 6 is still 30, like it's always been. You're still multiplying. It's just now that when I multiply these x's together, since they have exponents, I am going to add those exponents together. So 5 times 6 gives me the 30. X to the 2nd times x to the 7th gives me x to the 9. Same on this part. Multiplication is still the same. Negative 5 times positive 6 gives me a negative 30 this time. And again, I'm multiplying the same basis here. So once again, x times x, I'll add their exponents to get x to the 9. The last 2 parts of number 1. Second part of number 1. 2 different parts here. So let's look here. This says everything in this parenthesis is being raised to the 2nd power, right? I have a parenthesis, and outside that parenthesis, I have a 2nd power exponent. So what does 5 to the 2nd power mean to do? 5 times itself 2 times. So what is that part going to give you? 5 times itself twice gives you 25. Now do the exponent rule. What is the exponent rule tell me to do if I am raising a base, which is this x, to more than one exponent? What exponent am I raising the x to? I'm raising it to the 7th and the 2nd. So I'm using that power rule that says when you raise a base to more than one exponent, you're going to multiply those exponents together, which that's going to give me what? X to the 14. And the last part of number 1, again, this parentheses means everything inside here is being raised to the 2nd power. -6 is being raised to the 2nd power, and x to the 2nd power is being raised again to the 2nd power. So if you do -6 in your calculator to the 2nd power, you need to make sure you put parentheses around it. Because what does -6 to the 2nd power mean you are doing? Right, -6 times itself, which actually gives you positive 36. Now, what's the exponent rule tell me to do here? I'm raising this x, good, to more than one exponent, which means I'll multiply those exponents together and get x to the 4th.
So this is number 1.
Mm-hmm.
What is this?
5, 4. 5, 5, 5, 5. Right, number 2, you have 6x squared times 3x to the 9th. So we're multiplying, right? So the multiplication rules do not change. When you're multiplying plain numbers, you just straight multiply them like you always have. 6 times 3 gives me 18.
And then you
Not times them. When do you multiply? Times the exponents on those last 2 problems because, right, well, if you have, that's exactly right. No, so what do you do when you're multiplying the same bases? What does that exponent rule tell me to do with my exponents? If I'm multiplying the same bases, which is what I'm doing, x times x, I'll add their exponents together. So that gives me x to the 11th. So again, multiply like you always have done, add the exponents, right? Number 3, same thing.
multiply.
4a to the 4th times -8a to the 3rd Don't forget your sign rules. What do I multiply first? 4, positive 4 times -8. What's that going to give you? Negative 32. And since I am multiplying, what am I going to do with my exponents? Add them. So I'll have a to the 7. Number 4. Same thing, negative 2x squared times negative 3x to the 4th.
The
So what do you get when you multiply -2 times -3? +6.
And then you're gonna add.
Since you're multiplying, what do you do to your exponents? You're exactly right. You're going to add them. So what are you going to get? X to the 6. So the biggest mistake people make on these is they assume since they're multiplying that the rule says to multiply your exponents. You do not multiply your exponents unless you see like this. That's when you multiply exponents. When you've got an exponent on the inside and outside of your parentheses, that's when you multiply exponents. All right, a little different here. Got 5x times 9x plus 8. Now, what am I going to do? This right here, since I have a 5x, remember how you remove parentheses? You use that distribution property, right? You're going to distribute, which means you're going to multiply everything inside of this parentheses times 5x. So the first thing I'm going to multiply is 5x times 9x. So let's see, 5 times 9 gives me 45. What are you going to do with these exponents? I'm multiplying the same bases, right? They're both x's, which means I have to add their exponents, just like I was doing on those last few problems, which means I need to see their exponents. What exponent does this x have since I don't see it? Not 0, 1. Yeah. X means x to the first power. So when I multiply x times x, what does that give me? X squared, because you add those exponents together. 1 and 1 gives you that 2. So what have I done so far? I've done the 5x times the 9x. Now what do I need to do? 5x times 8. So what's the sign going to be? No, A. And 5x times 8 gives you what? 41x. Good. Now, when I get down here, I think, oh, wait, can I add that together? But why can I not? That's exactly right. They are not like terms. This one is an x squared. You're on fire today. This one's an x squared, and this one's a plain x. You can't add an x squared to it. They have to have the same exponent. Yep. Number 6. But I know you're gonna do your arrow 7 times 3, then 7 times 2, 2. That's exactly right. I'm gonna do the 7x to the third times all 3 terms inside that parentheses. So let's see, what do I have first? 7x to the third times 3x squared. So I'm multiplying. So what's the 7 times 3 give you? 21. Then I have x to the third times x squared. I'm multiplying. So what am I going to do with those exponents? So I'm going to add them, which is going to give you what? X to the 5th. That's right. And then this going to be a 1 exponent. Right, good. You definitely want to see that right here. Okay, so what's the first thing I have? So I'm done with the 3x squared. Now I'm moving on to this minus 2x. So what is this going to give me? 7 times 2. 7 times -2. Or you can go ahead and just put the minus. 7 times 2, like you said. 14.
and then
X to the what?
1, 3, and 1, so it's gonna be 4.
X
So
to the
it's-
4th. Good, because you're adding those exponents. So 7 times -2 gave me that -14. X to the 3rd times X to the 1. I added those exponents, which gave me X to the 4th. So I'm done with this one now. Moving on to the +3. So now I've got 7x to the 3rd times +3, which is going to give you plus 21. Now this one, it's like it just doesn't have any more x's to add to it. So if I start off with x to the 3rd and I don't have any more x's to add to it, I still just have x to the 3rd. This one didn't have any s on it to add any more exponent to that.
So where did you get the x from?
Because it has stuff right here.
Right.
So there's my final answer, right? I can't add any of those together because they all have different exponents and they're not like terms. So where did I get this x to the 3rd? Because what was I multiplying? I was multiplying 7x to the 3rd times 3. So that gave me the 21. And then this x to the 3rd didn't have any more x to add to it here, so it just stayed x to the 3rd. That's where that 21x to the 3rd came from.
Can you do another?
Yeah.
Can I do one off my homework?
Yeah.
Okay.
Tell me what your number 5 is. Number 6.
Okay. It is 6x to the 3rd power, parentheses 4x squared minus 6x plus 9. Or you could change that number if you want.
So that's fine.
Okay. So I know we're gonna do,
So 6x to the 3rd is going to go here first.
right?
So what's the number part going to give me?
6 times 4 is 24.
So 24.
And
What's my x is going to be?
it's gonna be 5.
X to the 5th, right, because you add your exponent. Done with 4x squared, right? Done with that.
Now 6 times, no, -6,
So that's going to give you,
5.
no,
No, -36.
right, because you have a positive times that. So minus 36.
And then that x is gonna be a 1, so 3 plus 1 is 4.
So that's x to the 4th. All right, done with this one. Now I'm going on to the +9. So what does the 6 times +9 give me? 54. What kind of x do I have?
To the 3rd power.
Right, I have x to the 3rd here, and when I come over here, it doesn't tell me to add any more x's to it, so I still just have x to the 3rd.
So do we write that in the box?
Yeah. Remember where your little exponent button is down at the bottom?
I'm gonna do a similar question.
All right, number 7. Same thing. Be careful with your signs. I'm going to distribute, right? So the very first thing I'm going to have is that one right there. So what is my number part going to give me? -6 times -2 gives you positive, right? Positive 12. What's your exponent part going to give you? X to the
6, 2, 3, 4. I thought you.
What are you going to do with these two exponents? You're going to add them together, right? You've got x2 and x2 to add my exponent. Good. X to the 4th.
Oh, this is gonna be -6.
So now, good. And now I'm going here. So let's see, you can think of this as having a 1 there, right? And a 1 exponent. I need to know both of those things, right? So what's going to be my number part? Negative 6 times positive 1, right? Minus 6. What's my exponent part going to be? I've got x2 and x1. Good. I've got x to the third. Drop the minus. Then I'm coming here.
Negative 42.
But look, a negative 6 and a negative 7. Positive 42. And what's my exponent? My x situation got to be, I've got an x squared here. No, this doesn't have any to add to it. So it stays x squared, right? So I had x squared here. When I took it over here, it said no more x's to give it. So it just stays x squared.
This number 8.
All right, this is a very important topic right here. It says use FOIL to multiply. Has this acronym. When you hear people say use FOIL to multiply, we are still just distributing. I am distributing this x to both everything in the other parentheses. So this x comes here and here. So where this acronym comes from, the F stands for the word first. And what that means is the first thing you're going to do in FOIL is multiply the first term in this parenthesis with the first term in that parenthesis. Then what do I do after I do that if I'm distributing? I go there, right? Well, the O stands for outer. What that means, after you do the first terms in each parenthesis, then you do the complete outside terms together. The complete outside, farthest outside from each other. That's what the O stands for, outer. So after you distribute the x, then you're going to start all over and distribute the 5 to both of those.
So I'm going to be in.
That's inner. The innermost terms together, all the way on the inside. So after you distribute the 5 to the x, then what do you distribute the 5 to? The 9. And this L stands for last. And what that means is multiply the last term in this parenthesis times the last term in that parenthesis. So a lot of times you'll hear people say FOIL, or you'll hear them say first, outer, inner, last. All that means to do is distribute. You distribute the x to the other parenthesis, and then start all over and distribute the 5 to the other parenthesis. So let's see what happens when I actually do this. Distributing the x. My first, what's x times x? X to the second squared. So x times x is x squared. Then where does the x go? What is x times positive 9? 9x. So I'm done with the x. Now I'll go to the 5 and distribute it to both of these. So what's 5 times x? 5x plus 5x. And then the last 5 times positive 9, which is positive 45. Now, a lot of times, probably 9.5 times out of 10, after you do first, outer, inner, last, you will have like terms to combine. Which of these terms in this list can you put together? These x's, right? 9x and 5x. So now I'm not multiplying anymore. I'm combining like terms, which is adding, which means when I put these two terms together, I'm just going to have more x's. I am not going to get into an x squared situation, right? How do you get x squared? X times x. I'm not timesing, I'm adding. So let's see, when you, I don't have anything, no like terms with this one, right? So it's just going to come down.
So 14x plus 14x.
Good. 45 plus 45. That's exactly right. So all that happened was you combined the 9x and the 5x together. There's no reason to write 9x and 5x separately when you can just as simply write 14x and it means the same thing. All right, I'm going to put another one like this on the board. So just, I want to get used to this just becoming second nature. Careful with your signs here. So first, x times x, which gives you x squared. What's after first?
The outer.
What does outer mean? All the way outside, which is going to be what?
X times 5 is 6x.
So positive 6x. What do you do after you do the outer? Then you're going to move to the very inside, which is -7 times x, which is -7x. First, outer, inner, then I move to the last. What does that mean? It means the last term of the first parentheses times the last term of the second parentheses. So what does that give me? -7 times positive 6, which is -42.
And you don't have no loss.
What about them?
You do have loss.
They're x's.
So it's going to be 6 minus 6.
6 minus 7.
Going to be -1.
-1x. So I'll bring down my x squared. Not plus. Minus 1x, or just minus x. Minus 42. All right, number 9. Again, these last two problems are still just more FOIL. These are both going to just still be FOIL. First, outer, inner, last. And the way you know that it's FOIL is because you have 2 parentheses. And in both parentheses, you have 2 terms. Like this, number 9, 17 minus 5 times 17 plus 5. So I have 2 parentheses, right? And I'm multiplying them together. And in each parenthesis, there's 2 terms. That's how I know it's FOIL. So what's first in FOIL? 17 times 17. 49. What? T. Oh, T squared. Good. Good. 7 times 7 gave me the 49. Since they both have T, I have T times T, which is T squared.
And then 17.
What's after first?
Added.
All the way to the outside. So what do I have? 17 times 5, which gives you what? 35t. That one's not t squared, right? This one had a t, but this one did not. What's after outer? Inner, which is going to be what? Negative 5 times positive 17, which is going to give me negative 35t. So I've done first, outer, inner, and what's next? Last, which means the last term in the first parenthesis times the last term in the last parenthesis. So what's that going to give you? Negative 5 times positive 5, negative 25. These terms are both t's, right? What happens when you put those together? So you don't have any t. They completely cancel each other out, don't they? You've got positive 35 and negative 35, which means you don't even put t down here. Because if you put t, what does that mean you're saying? A t means 1 t. I don't have any t's left. They completely cancel each other out. So all you're left with is the 49 t squared and minus 25. Last one, number 10. X plus 2 times nx plus 2. I'm going to FOIL, right? 2 parentheses. Each parenthesis has 2 terms. So my first 8x times 8x gives me 64. What? Do they both have x's on them?
Yep, so
X squared. After first, I'm going to do my outer. Positive 8x times positive 2, which gives me positive what? 16x, right? And it's just an x, not an x squared, because this one has an x, but that one didn't. So I've done my first, done my outer. Now I'm going to do my inner.
No, 2 times 8.
2 times 8x is another positive 16x
Plus.
First, outer, inner, then my last, the last term of this parenthesis times the last term of that parenthesis, which gives you positive 4. And once again, these are both x's.
And they count.
They don't cancel out this time. Why not?
Oh, because it's adding.
They're both positive 16. You've got 32 x's is what you have. No. Why not x squared? How do you get x squared? X times x, right? And that is the biggest mistake, is that people want to turn that when they put these 2 terms together into x squared. But I'm not multiplying x times x. I'm adding 16 x's to 16 more x's. So I've got 64 x squared plus 32x plus 4. All right. We're going to do 5.7 also. It only has 4 problems.
but they long
No,
problems.
they're not. Well, it's plenty of time to do homework. Yeah.
Wait. Hold on, before you get to there.
Okay.
You do one more problem.
Uh-huh.
Back to number 6.
Okay.
No, number 6. I'm sorry. Got negative 3x squared parentheses negative 2x squared plus x minus 6 parentheses.
Okay. So this isn't 4. This isn't first outer inner last. The same process. It's still distributing.
Right. So we're gonna do negative 3
Times.
times negative 2, which is positive 6.
What are you going to do with these exponents?
So 6x and then 2 plus 2.
Right? Which gives you x to the
4th power.
So now you're done with this.
Right.
Now where are you going?
Negative 3 times 1.
Which gives me
3.
okay. So that's going to be minus 3.
Minus 3.
This one this is x squared. This is x 1.
So it's gonna be negative 3x.
Negative 3x what?
3.
Not squared.
1. No.
What are you doing with those? You're going to add them, right?
3.
Yep.
Okay.
So done with this. Now we're moving. Negative 3x squared times negative 6. So what's my number going to be? Negative 3 times negative 6?
Negative 18.
Not negative. What's negative times a negative?
Oh, positive 18. I'm sorry, I wrote that wrong.
Positive 18. So now this one has x squared, and this one doesn't have any x's to add to it. So it's just still what?
X squared.
Right. There's no more x's to add to that. So that was multiplying.
Now we can do quotient.
Quotient, which is dividing. Okay, before we get to that problem, let's just remember how division works. Let's see, 6. This fraction bar means divided by, right? That's what a fraction bar means. The top divided by the bottom. So 6 divided by 3 would give me 2. What about the exponent rule? What was the exponent rule that we learned last week? When you are dividing the same bases, you are going to subtract their exponents. The top exponent minus the bottom exponent. So this one would give me x to the second. So we're just going to combine those two things now. So over here, back to the problem. Anytime you've got a fraction and there's more than one term in the top, but only one term in the bottom, that means they're actually both over that 6x. So I think a way, even though it's writing more stuff, to make it look simpler and to understand exactly what's happening, since they are both over 6x, write it like that instead. Write it like this, 30x to the 4th over 6x minus or negative 18x to the third over 6x. So these two things say the same thing. The top, these are actually both over, the 6x is the denominator for both things. So that's why I just wrote it separately. Now, let's see what we're going to do. What happens? Let's see. But just like always, what is 30 divided by 6? 5. What is x to the fourth divided by, what does this x have as its exponent? 1. What does the exponent rule say to do when you are dividing the same bases? You are going to subtract their exponents. So what's this going to leave me with? X to the third. Minus, what's 18 divided by 6? 3. X to the third divided by x to the 1. Subtract their exponents to get x to the second. And that's your answer. So when you have a fraction that's got this one term in the bottom, I highly recommend rewriting it each separately and giving them each that 6x. And then just work them kind of like separate problems. Let's do another one before we move on.
Okay, so
I'm going to go ahead. I'm going to rewrite it first. Even though it takes a little bit of extra work on the front end of the problem, it just makes it easier to see what's happening. So I'm going to rewrite it as 45x to the fifth over 5x to the third, then minus 20x to the fourth over 5x to the third. Right, so it takes a little bit of extra writing at the beginning, but now it's like I'm just working two separate problems here. What's 45 divided by 5? 9.
And then 5 minus 3.
So that it gives me x to the second. Bring down that minus.
And then
20 divided by 5.
4.
4x to the fourth over x to the third. What do you get? Just x, right? Because when you subtract those exponents, you get a 1. And x to the 1 is just the same thing as saying x. All right, now let's move on to number 2. The only thing that's happening in number 2 is just a little sign. Got to be careful on.
This 5.
30x to the 6th minus 36x to the 5th plus 18x to the 3rd. I know. All over negative 6x to the 3rd. Again, highly recommend rewriting it and giving each term in the top its own negative 6x to the 3rd in the bottom. So I'll have 30x to the 6th over negative 6x to the 3rd minus
36x to the 5th.
36x to the 5th. Right? Give it its own negative 6x to the 3rd. And then what's the last thing?
Drop the plus.
Plus 18x to the 3rd over negative 6x to the third. So everybody gets their own negative 6x to the third. So on the first fraction now, what's 30 divided by negative 6?
-5.
Negative 5.
And then x to the third power.
Right. Subtract those exponents. X to the 6th over x to the third is x to the third. What's negative 36 divided by negative 6?
-6.
Not negative.
Yes, it is. Oh, negative to negative.
Right, because it's a negative on top of a negative, right? Positive 6.
And then to the second power.
X to the second, right? Subtract those exponents. What's this one going to be? A positive over a negative, which is going to make this negative 18 over 6, which is what? 3. What happens when you subtract those exponents? It's nothing. You don't have any x left. What does this mean? Now, don't write this. This is not right. What if you put an x? What does that mean? That means you have x to the first power, right? 3 minus 3 is not 1. You don't have any x left. So that's why it's just minus 3 at the end right there. All right, 2 more. Number 3. (14c to the 4th). Minus 10c to the 6th. Plus 10c to the 8th. Over 2c to the 4th. So who is everybody's denominator? 2c to the 4th. So let's write it like that. Everybody gets a 2c to the 4th in the box. So 14c to the 4th over 2c to the 4th minus 10c to the 6th over 2c to the 4th plus 10c to the 8th over 2c to the 4th. And then it's like now you're just doing 3 separate fractions. What's 14 divided by 2? 7. When you subtract these exponents, you get no c. So it's just a 7. Minus 10 divided by 2 is 5. C to the 6th divided by c to the 4th gives you c to the what? 2. Because you subtract those exponents. Plus 10 divided by 2 gives you 5. C to the 8th over c to the 4th, which is c to the 4th. Good. Last one. We can do homework. We have plenty of time to get it done. Negative 9r to the 4th plus 4r to the 3rd minus 2r squared over negative r to the 3rd. So we're going to have some issue on this. Hold on. Let me it'll say. Even if you don't click it, if you just where's that? Oh, yeah.
Yeah, I'm trying to go.
Is that okay?
go. Number 4. Mhm.
So I'm going to rewrite and give everybody a negative r to the third in the bottom. So I've got negative 9r to the fourth over negative r to the third plus 4r to the third over negative r to the third minus 2r squared over negative r to the third. All right, so let's see. And these all have ones, right? So let's see, negative 9 divided by negative 1 gives you positive 9, right? A negative over a negative just turns that positive. How much r do you have left? R to the fourth over r to the third leaves you with just r. So done with that one. What's a positive 4 divided by a negative 1?
Negative 4.
Negative 4.
And nothing.
And nothing. Moving on to this one. Negative 2 divided by negative 1 is positive 2. Be careful here. I have r to the 2 divided by r to the 3. I have to do my top exponent minus my bottom exponent. So what is that going to give me? R to the negative 1. I can't leave an answer with a negative exponent. What did we learn last week fixes a negative exponent? Where does that R need to go? You flip it to the bottom. So the 2 is fine. It doesn't have a negative exponent. The only person that has a negative exponent is this right here, that R. Everybody else is fine. So let's see, I've got 9R minus 4 plus the 2 is fine. I need to put the R in the bottom, right? That's what fixes it. Putting the R in the bottom of the fraction turns its exponent to positive 1, which means I don't even have to write its exponent, right? Because R to the first power is the same thing as just saying R. So that's your final answer on that one. So you just have to fix that negative exponent at the end by moving the R to the bottom. So on Thursday, we are going to be reviewing chapter 5 because your test is this Sunday for chapter 5. So we're going to review on Thursday the whole chapter. Remember to take your review a bunch of times before you take the test. Also, sending me your scratch work is going to be very important on this test because of the way things are entered in. Sometimes you may enter an exponent in the wrong spot or something, but if I can see your scratch sheet and see that you had 3x squared, but instead when you typed it in, you put 3x and then you put the 2 next to the x instead of up in the exponent or something, MathLab's going to mark it all the way wrong. But if I can go back and look at your scratch, I can give you full credit for that problem, right? You just typed it in wrong. You did the right work. So it's very important that you send me your work on this test. We'll talk more about that on Thursday.